Hi, welcome back to Missing Chemistry. This is chemical equilibrium problem again. And in this case, we have a 0.05 molar of H2 gas and a 0.05 mole of bromine gas are placed together in a 5-liter flask heated to 700 K. What is the concentration of each substance at equilibrium if Kc is equal to 64 at 700 degrees? Not 700 Kelvin. Sorry about that. Okay, anyway, so now first of all, let's write our balanced equation. So we have H2 gas plus Br2 gas, and they're both diatomic, and we're saying that it's at equilibrium, so we're going to make something called HBr. Well, they both have 2, so you need to put a 2 there. So everybody's balanced, and this is also going to be a gas. So we now know that Kc, like Kq, is going to be, of course, products over reactants. So we know that. But now we need to figure something else. Oh, look, it's a 5-liter flask. That's important. So what we're going to do is we're going to take H2, which is 0.05, and divide it by 5 to get the new molarity. And then Br2, which was also 0.05, divided by 5 to get the molarity. So this is going to give us a molarity for H2. It's going to be 0.01 m, and for Br2, it's going to be the same. 0.01, and that's molarity. Alright, so far so good. Alright, now we're going to want to set up the Rice table because we don't have all our numbers. So the first thing we're going to do is we're going to go Rice R, so we'll write the reaction, which is H2 gas plus Br2 gas at equilibrium yields 2HBr. That's also gas. So our initial concentrations are going to be 0.01, 0.01. We get that from here and from here. And since we haven't made anything yet, our initial concentration is 0 for HBr. Alright, now, the change. We're going to go down by x. We're going to go down by x, and we're going to increase by a positive 2x. So, evaluation. This is going to be 0.0 minus x, 0.01 minus x, and simply 2x. Alright, now we can go and do the math part. So we got to figure out what the value of x is and place it back in there. So let's look over here. So we're going to set up, the Kc is 64, right? So we're going to go 64 equals 2x squared. Why that 2? Because of that 2 right there. Over, that's our products, over our reactants, which is going to be 0.01 minus x times 0.01 minus x. Hey, wait a minute, we got 2 of the same. Okay, so we'll set it up as 64 equals 2, I have troubles writing here, guys, for some reason, x squared over 0.01 minus x squared. Do you see what I see? We've got perfect squares. So we can take the square root of this side and square root of that side. And when we do, we get 8 equals 2x over 0.01 minus x. Now, in some of the other problems, we've been able to throw x out because, if x, remember that if x is less than 0.001, we can throw it out. But x is 8, so we can't get rid of that. I mean, forget it. Got to keep it. All right, so now you're going to do the math. This is going to give you 8 times 0.01 minus x equals 2x. So we're going to bring the math up here. So this is going to give me 0.08 minus 8x equals 2x. So 0.08 equals 10x. X equals 0.008. So now we have our x value. That means we can plug it back into here, here, and here to get our concentrations. So we're going to go for H2, 0.01 minus 0.008. For Br, 2, there we go, hang on for 1 second there, guys. There we go. Box that just to make it look neater. 0.01 minus 0.008, yep. And then, of course, for 2HBr, it's simply going to be 2 times 0.008. All right, let's get this done. So when we do the math, our H2 is equal to 0.002. Our Br2 is equal to 0.002. And our 2HBr is equal to 0.016. And these, of course, have molarities with them. Or they don't. We can just that out. Not necessary. Okay, there we go. And you know what? That's it. Those are our answers. You guys be snarly, and we'll see you back here at Moosing Chemistry.